6.3 logarithms. So logarithm is actually an inverse to an exponential. And that's how logs became about, because they were used to rewrite an equation that allows you to solve for the exponent. For example, 2 to the power of x equals 6. How can you identify it? Well, you can rewrite it in a different form such that you can put it in your calculator to solve. So how do you rewrite an exponential and a log? This definition is really important in terms of understanding how to use logs. And so you have to know this idea. And it's a way to convert between exponentials and logs. For example, if you have a b to the power of x equals y, then you know that log base b of y equals x. So this base here is the same as the base of the log. And you also know that logs equal exponents. Logs are always exponents. So when you see the log equaling an exponent, notice that there's an exponent right here. So that x is going to come down for this x. So the bases are the same, and logs equals exponents, and then the y just gets filled in. So how do you solve some of these problems? First of all, how do you rewrite it? Well, again, the base starts with 2, exponent is 4, equals 16. Base is 4, exponent is 0, equals 1. 12 to the 1 equals 12. 1/4 to the negative 1 equals 4. Rewrite each equation in log form. So we're going to start with the log of base. So log base 5 of 25 equals the exponent. Log of the base 10, the number, equals the exponent. Log of the base, log base 8 of the number equals the exponent. Evaluating. So this actually means, what does it equal? It equals something. So what we can do is just say 4 to the box, or something, is equal to 64. 4 to what power equals 64? A couple ways of knowing that. You could say, oh, it's just going to be 3, or you could also say, well, 4 to what power equals 4 to the third power? That exponent has to be equal to 3. Same idea here. 5 to what exponent equals 0.2, which is the same thing as 2 over 10. Now that makes that a little bit easier, 1/5, and you know that this is going to equal negative 1. 1/5 to the power equals 125. All right, so this is 5 to the negative box equals 5 to the third power. The negative box equals 3, so the box is equal to a negative 3. If you set it equal and get the bases the same, the exponents have to be the same. Now, one other idea on logs, and this is a very long section, so I'm going to break it down into thirds, but there's a common log and a natural log. Common logs will be written as just log x. And what that really equals is log base 10 of x. In other words, there's a 10 that is going to be the base in every common log. And the second one is the natural log. The natural log has a base e. And you can rewrite log base e of x as ln x. Notice there's no base here. The base is always going to be e, and that's how those are going to equal. So if we have a calculator. They have two um, two logs. One is where there's a base 10 and the other one where there's a base e. So you could just plug that into your calculator. Remember, it's just got to be the log of 8. That's the common log of 8. Really, there's a base 10. 10 to what exponent equals 8. And in this one, there's a hidden e to what exponent equals 0.3. But there's a common log button and a natural log button in your calculator to find out those answers.